Hi everyone. So this series we are solving the LeetCode daily questions. So today we'll be solving the unique path question. Okay. Yeah. So this is actually, to be very fair with you or to be very frank with you, this is a very important question which is being asked in many interviews, many companies. Okay. And whenever you find a question where you need to find number of ways, how many ways this can be done and all those things, right? Try to think in terms of dynamic programming. And if you don't know about dynamic programming, I'm basically releasing I'm going to release a new playlist or develop a new playlist on the dynamic programming in a short while. But let's see how we can solve this question. It's very fairly easy, and it's a medium question. So and we're gonna see that how we can actually solve it in almost the best possible way. This robot wants to go to this finish position, and this robot can take only two types of steps. Either this robot can go down, or this robot can go towards its right. Okay, this robot can take either a right step or down step. So we have to find how many ways this robot can reach to the finish position. Question is clear, right, folks? So let's directly jump and see how we can actually approach this. Understand this thing. To solve a question, find a base cases. So how many number of ways this robot can actually go to this cell towards its right, immediate right? Number of one ways, right? The robot can just directly go there. Now how many ways robot can go to this cell? There's only one way. Robot can just directly go to that position, right? There's no other way to reach here using traveling one right and one down thing, right? If your robot is going down, this he cannot reach to this position then, right? So there's only one way. So in this way, this upper row can be reached only one time by this robot, right? And similar to this thing, so the first column, there is only one way. Robot will keep on going down and he can reach to that particular cell only one time, right? So to reach to this particular cell, there's only one way. To reach this to the particular cell, there's only one way. And if there's any number of rows there, so there would have been only one way of reaching there, right? Now the catch here, since we have set our base condition, now how many number of ways robot can reach to this cell which I'm highlighting here? Think about it, right? So let's think logically. Okay, so robot can either go towards its right first and then take a down, right? So that is a one way, right? It can go towards the right and then go down, so that is a one way. Or robot can directly go down and then take a right, correct? So there are two ways. Got it? So there are two ways to reach to this cell, right? How many ways are there to reach to this cell, right? So there are two ways to reach to this cell and there is one way to reach to this cell. So number of ways to reach to this cell is gonna be 3, right? Now I think you guys would have found the pattern here, right? At any point, at any cell, right, any n cell or nm coordinate cell, robot can reach to that particular cell by, we can actually calculate how many times, number of ways to, robot can reach this particular cell and number of ways robot can reach this cell, right? And if we add both of these numbers, we will find that number of ways robot can reach to this particular cell, X cell, say, right? So what is a recurrence equation? We're gonna use a dynamic programming to solve this thing. What is a recurrence equation, right? And this is a basic pattern which you will follow to solve any question which is asking for how many ways, number of ways robot wants to go here, there, right? This is the same pattern which you're gonna follow. Now let's see what is the recurrence equation here, right? So yeah, so grid, say there is a coordinate called xy, right? How many ways, if this is a coordinate of the x and y, right? How many ways robot can reach to this point, right? So it will be grid. We said that number of ways to reach the immediate top cell, and number of ways, number of immediate, left cell, and immediate left gonna be x I minus 1, right? That's all, and we have solved the problem. Dynamic programming is all about, guys, forming a recurrence equation. Once we form the recurrence equation, it is done. Let's see, right? So I have already wrote a code, fairly simple, running almost the best solution which is being given in the Java. Let's see how it runs, right? So we discussed about that, what are the base conditions, right? The number of ways to reach to the first row is basically one way, right? All the cells will be one. A number of ways for this robot to reach, to travel any cell in the first column is basically only one ways, right? We discussed about that. So I'm just doing that number of ways, I'm filling these cells with the 111 values, right? Horizontally and vertically. If question is asked, how many ways robot can reach to a particular cell, here, I'm just filling the base conditions here. Now we have found our recurrence equation. What was our recurrence equation? If we want to find, this cell, the number of ways robot can reach to this particular cell, number of ways robot can reach to this particular cell, add them, you will get the solution. So there's a one catch here, right? So we have already filled this first row and first column. We have to start from this cell, right? Now we have to start from this cell. So what are gonna be the coordinates of this cell, independent of whatever the size of the grid, gonna be 1, 1, right? So we're gonna start from the first row, first column, iterating over the rows and column and following our recurrence equation, right? So number of ways I can go towards if I'm coming from here, number of ways I can reach here, number of ways I can reach here, adding them and getting it to the final solution, right? This way we are actually eventually reaching the final solution here and returning these coordinates, right? Returning the number of ways, whatever the number we have formed in the 2 by 2 grid here. That's all, right? If you submit this solution, I hope you guys would have understand this. Yeah, almost the best possible way it can run, right? 100%. It is faster than 100% of the Java solution which is being submitted here, right? Fairly easy. We just went by the intuition, right? And solved the question. Thank you so much. If you haven't liked and subscribed to my channel, please do that. See you in the next video.